start with sort of, where are we right now? We have the idea of a vector space, and we have sort of two representations of it. One is via the 10 properties.
I don't know if you know, but the projector is off. Please.
Yeah,
I don't know if you're showing anything on that.
Okay, so I'll come up in a second, hopefully. And so the first thing, you know, vector space, and it has 10 properties. And the second one is the V equals the span of some set, which oftentimes is often smaller. Okay. So this is sort of the external sort of characterization. This is the internal characterization. And so, but the key idea is that when you show that any vector space can be written as a span, and some of the vector spaces, we have the big vector spaces. You know, we have the big four. We have like R, C to the N. We have the arrows in Euclidean spaces. We have the polynomial spaces, and we have the various matrices as vector spaces. In each of those are the big spaces, but then we also have subspaces of all these, and these subspaces are also spans. So everything's a span, but these subspaces generally correspond to solutions of homogeneous linear systems. So there's a sort of all these things sort of correspond. Like, you know, there's a correspondence between vectors in the column vectors and arrows here. And so when I look at a subspace here, it has a geometric picture as a flat space inside the Euclidean space. So this is sort of our picture, but then what it turns out, because of this connection, this is sort of the natural context for solutions of homogeneous linear systems to understand what the linear systems are doing. And when we come to the next topic after this one in chapter 5, which is a further ways away after the spring break, we come to linear maps, and that tells us more about how linear systems themselves work in terms of vector spaces. Right now, it's sort of like just the idea of vector space sort of captures the idea of a solution of a solution, right? And the idea of a linear map is going to tell us about what the linear system itself is doing. So anyway, so that's just sort of a preview. Maybe it sounds more mysterious than informative. Okay, so what it turns out is that there's the essential, the most important concepts are all based on this idea of spans, and they are linear concepts in linear algebra. Okay, that's linear independence, right? And the second one is basis, and a basis is crucially related to linear independence and dimension. And dimension is a property of bases. So these are all really sort of all related ideas. But these three words or three concepts are sort of at the heart of terms that are used in linear algebra. So they're the sort of the important concepts. And they all they are all based on the vector space as a span. Okay, so they're all features of span of writing vector spaces as span. So that's sort of the overall picture that there's going on, and so now we can review the idea of a span. But first, are there any questions about